Welcome to the Insightful Professor. Today we're going to be discussing primitive data types in the Java programming language. So the first question probably comes up is, what are we concerned with data types for? Well, the motivation for data types lies in what I'm going to describe here. Computer memory consists of sequences of ones and zeros, what we call binary values. These ones and zeros in computer memory could be subject to different interpretations. A sequence of ones and zeros could represent an instruction to the computer. That is something in machine language that the computer understands. It could represent a character. Any of the characters, letters, digits that you see on the keyboard, each of these would be represented as a sequence of ones and zeros, a binary value. They could also represent a genuine numeric value with which we might wish to do arithmetic. So the point that we have here is we want to be confident that the computer is assigning the correct interpretation to these sequences of ones and zeros that we had envisioned being assigned to them. That is, if this sequence of ones and zeros is to represent a character, then it doesn't make sense that the computer should try to do arithmetic with it. So we want to be sure of what's out there. So when we allocate memory, we allocate chunks of memory or some quantity of memory where the ones and zeros will be stored. So how is it that we're able to specify that, oh, this is going to be treated as character data and you can't do arithmetic with it? Or this is treated as a number and it makes sense to do addition and subtraction operations? Well, the secret to this is to designate a chunk of memory as being of a particular data type. Now, in Java, there are 8 primitive data types. These are data types that are understood by the Java programming language. We don't have to do anything to make Java aware of these data types. This is integrated within the core language. Java is an object-oriented programming language. So what this means is we have the ability to define classes and objects. So what is a class? Well, a class could be thought of as a user-defined data type. See, in addition to the primitive data types that kind of come automatically with Java, we have the ability in an object-oriented programming language to extend the expressiveness of the language by adding our own kind of custom data types. These take the form of classes. In this particular video, we're going to be focusing on the primitive data types that are built into Java. In future videos, we'll talk about defining our own classes, kind of extending the language. But in order to use the primitive data types, we need to do nothing. Java is already aware of these. So what are the characteristics of a data type? Well, when we declare something as being of a data type, that is, allocate a chunk of memory and say this memory is going to be treated as a character, or this memory is going to be treated as an integer, and so forth, what happens is we're specifying a data type, and that data type will determine how much memory the Java compiler will allocate, the size of memory. That data type will determine what are the valid or permitted binary values for this chunk of memory. And finally, the data type will indicate to Java what operations make sense, what are valid operations that can be performed on the binary values stored in that particular memory location. Now, related to the concept of a data type is something called a variable. When we declare a chunk of memory, we intend to store values in there and subsequently refer to that chunk of memory so we can retrieve those values or look at them or update the values, change the content of memory. But instead of having to say, hey, at this particular location and use some memory address, we can associate an identifier or a symbol with a memory location. This symbol or identifier is referred to as a variable. So a user defines a variable a name or an identifier, and at the same time says this will be associated with a particular chunk of memory that will be of some particular data type. And then we get the three things that we just talked about. How much memory, what are the range of values that can be stored there, and what operations can be performed. Now, in Java, a variable must be declared explicitly before it can be used within your program. That seems perhaps obvious, but not every programming language follows that rule or has that requirement. Each variable will also be associated with a data type, and as a consequence, we say that Java is said to be a strongly typed language. Another way of looking at it, there's a term called statically typed. In essence, what this all means is that the variables must be declared first before they can be used. Now, let's look at some of the data types. There's a category of data types in Java for the primitive data types called integral data types. An integral data type is a data type that represents some range of mathematical integers. So integral data types in Java are of different sizes, and they all allow for positive and negative values. So the size actually determines the range of permitted values. So what we have is byte, which is simply an 8-bit signed integer represented in a format called 2's complement. The range of values would be -128 to +127. A little bit bigger is short, which is a 16-bit signed integer. Again, 2's complement is the representation form. And a range of values would be -32,768 up to +32,767. Integer is a 32-bit signed integer, and this is simply abbreviated int. Now, all of these are integers, but they are different sizes, and they have slightly different names to inform the compiler that I'm using, an 8-bit or 16-bit or 32-bit or 64-bit version of the integer, which again determines the size, obviously, but also determines the range of values. So with int, because it's 32-bit, the range goes from -2 billion up to +2 billion. And with 64-bit, very big number. What we have is 100, 1,000, million, billion, trillion, quadrillion, quintillion. So -9 quintillion up to +9 quintillion. Pretty big range of values there. But again, these are all whole numbers or integers. If we wish to have kind of fractional values, then we use something called a floating point number. And Java has two varieties of this. Something called float, which is a single precision floating point number, represented using 32 bits, and double, which is a double precision floating point number, represented using 64 bits. Both of these floating point data types in Java adhere to the IEEE 754 standard. Now, how would we express a value if we were to inject it into the program and use that value then to be assigned to a variable? Well, in the case of floating point, we have what's called a literal. Well, actually, in any of these data types, we'll have a literal. And a literal is a source code representation of some fixed value. Here, the literal that we could use for a floating point value would be something like 3.14159. This particular format is called a standard notation, as opposed to this form here, where we say 3.14159, and then we have the letter E to indicate that there's an exponent to which the base of 10 will be raised, and then what that power is. In this case, the power is a negative number, -0.5. And what that means is go to the end of the digits displayed here and start moving the decimal point to the left this number of positions, 5 positions. So what we would end up with is 3.14159 once again, but this is expressed in what's called scientific notation by using this E and giving the exponent to which the power, so for the power of base 10. And of course, if we had a positive number, then we're going to be moving the decimal point or the radix point to the right from what we are presented to precede the letter E. So the next question that might come up is, how could we distinguish between these two numbers as being, say, single precision or double precision? What would happen is we could append to the literal value that we're introducing the letter F, either in lowercase or uppercase, and that would give us a float or single precision value. Or we could append to that number a D, lowercase or uppercase, and that would give us a double precision number. And again, we give a couple examples here, 3.14F, 3.14D. The values represented are essentially the same, but the precision or the accuracy is different, being single precision or double precision. If we were to simply use something like we were showing here, 3.14159, and we were silent as to whether this was single precision or double precision, as noted at the bottom of the current slide, what we see is it would default to double precision. So we want to be careful about that. Now, there are 8 primitive data types in Java. We've just shown you 6 of them. Those are all numeric. Here are the remaining 2. One data type is called Boolean, and this, we don't really know what its internal representation is. We're kind of shielded from that, or it's shielded from our vision. But the 2 possible values here are true and false. So those would be the actual values we would use if we were to assign a value to a Boolean storage area. These are often used to have kind of switches to control the flow of execution within a program, where we'd have these switches or flags that simply can assume a true-false value. We test it and conditionally take some action. Very commonly used. The final data type here is char, which is a 16-bit chunk of storage, 2 bytes, but it represents a character according to the Unicode character code. And that's a little bit different than ASCII. Okay, this is a kind of multi-byte character code using 2 bytes, whereas ASCII is just an 8-bit character code. The literals that we would use is we would have a backslash and then say a lowercase u followed by 4 digits, the 4 digits each representing say half of a byte or 4 bits. And we could have all of those digits 0 up to all of those digits being 1, which would be reflected as hexadecimal zeros or hexadecimal Fs. Now that we understand data types, or have some idea of them, how do we use them? Well, we can declare a variable, as we said, and associate it with a chunk of memory. And by specifying the data type, we get the benefits of what we were talking about previously, understanding the quantity of memory, the permitted range of values, and also permitted operations. But when you declare a variable, you're associating a user-defined identifier or programmer-defined name with some chunk of memory. So instead of having to worry or be concerned about the location of memory, we simply take a look at a symbol, an identifier, and the system maps it to whatever that memory location is. Very nice, very convenient for us. Now, we'll talk much more about variables in a later video, but at this stage, we simply want to give you a more complete exposure to the idea of using a data type. So here we have a little program called primitive types. And within this, what I've done is I've declared a variable called var1 and designated its data type as int, which means 32 bits will be allocated in memory, and var1 will be able to give me a symbol that can access that 32 bits. So I'm assigning a value. This is an assignment statement, taking a value of 200, which is clearly within our acceptable range for int, plus or minus 2 billion, and we're taking that and assigning it into the storage associated with the variable. Then we have a second variable down here, which is of type byte, also an integer, but again, it's only 1 byte of storage, so it's a smaller range. And finally, short, which is 2 bytes of memory, where we can put an integer. Now I'm calling that var3. Let me just show you one interesting little thing here. Let's take var2, which is a byte, which means -128 up to +127. Suppose I attempt to put something outside of that range. You can see that the IDE immediately catches that and highlights this line by underlining it. And what we see is it's telling me that this particular line is trying to assign a value that is outside of the permitted range for this particular data type. So it won't let me do that. So it's actually being caught by the IDE before I even attempt to compile the code, let alone run it. So let me change this back to 20. So with the value now set back at 20, I'm going to go ahead and compile and run the program, and we'll see what effect our variable declarations and assignments have done. So I've again declared a variable, assigned a value, and then I've used the variable in this call to system out println, the println method for system out, and simply I'm dumping the value to the screen. So I'm saying the name of the variable, whatever it is, var1, var2, var3, the value is, and then I'm accessing memory symbolically. And notice we get var1 value is 200, var2 value is 20, var3 value is 200. So it worked quite nicely. So the point is that we can declare our variables of being of a particular data type, and as we saw, it does have an effect on the permitted values. Let's go back and wrap up this section. Now, the file that I just showed you can be obtained from my website, www.timhartley.com. Simply go to that website and find the menu and look for the link that says Insightful Professor. Click on that. You'll be brought to the web page that has all of the code for examples on the YouTube channel. So you'll find a file named Primitive Data Types, and it will have the source code for that particular application we just looked at. So hopefully you found the whole video to be helpful and informative. And if you want to offer any comments, we'd welcome those. And also, if you enjoyed it, give a thumbs up. One other thing is consider subscribing to the channel. Just click on the little owl icon, and we can keep you apprised of when we add new videos. And finally, thanks again for watching.